Fortunately, the globers have got an explanation for that, because you're not paying attention to the parallel light rays. That means we can measure these angles with respect to the centre of the globe and turn the globe like it's a protractor, which is what they actually do. But all that really means is you're measuring a flat Earth.
Very simply, it debunks the globe because the stars are not moving in accordance to this stick and arm pointing towards the star. They are not moving in that manner. So if you remove the Earth,
manner you're talking about, well, the manner you're talking, like you're trying to say it'll debunk a globe. How will it debunk a globe when the example I've given you is they'll be using a flat stationary plane for all their calculations? So that's what you're claiming. So how can it debunk that without debunking flat Earth as well?
But they cannot use flat Earth if we're starting from...
I just went through it with you a few minutes ago. When they do their calculations, they'll be using a flat stationary plane at equinox. So there won't even be a tilt. They won't have a tilt. They won't have a globe. They'll have a flat stationary plane, an extended plane at equinox. That's how their calculations work. So when you're looking for the answer, they'll come back to you with the answer. Then they go and show it to you in Stellarium. You think they haven't come true? You think you have some big proof? You don't. I'm sorry. You don't have it.
Hang on. Slowly. If you allow somebody who's arguing against you to start with your model in order to prove their model, then you have a bigger problem than I'm trying to talk about.
Yeah, that's them. Exactly. Now you're getting it. They have a bigger problem to face. The globers have a bigger problem to face because they need our flat Earth measurements to derive their sphere inference. That's a bigger problem.
Well, exactly. That's a big problem.
That's a big problem for them. And we've spent at least an hour and a half now trying to explain that first you have to make your opponent recognise that they're using flat Earth measurements. Once you've got that, that's the end.
I will not allow them to start arguing against flat Earth by starting from flat Earth. They have to start from their own model. If they use some facts from the flat Earth model, I would say, no, that fact does not belong in your model.
Perfect, we're getting somewhere. Okay, good. Perfect. So when you come to these examples with any example that's pointing lines at stars, in all cases, they'll be operational for a globe from the centre of the globe in what Brian just described as the extended plane at equinox. That is what they will be using.
And my example works perfectly fine with that. If in that example, you will be pointing that stick from the center of the Earth at Polaris, and the arm will go from the same stick, even though if it goes from the center of the Earth, that arm will still be pointing at any celestial object and will be able to track it by rotating the stick 24/7 all the time.
Right. Okay.
Correct
perfect.
Or not?
Perfect. So flat Earth proven, because the globe's being wrapped around that plane that the angle's coming from at the centre of a sphere that you're not using for the measurements. What you're actually doing is proving a flat Earth, because that's how the measurements have just been described. You'd say, well, in this instance, it will work at the centre of a globe. No, at the centre of a globe is on the equatorial plane, and that's where you're actually standing if you're making these measurements with respect to the stars. You're on a flat plane, measuring from the surface. You're not in hell, you're not in the middle of a globe, but that's how they'll describe it. And when they do, the description does work, because that's how the globe came to fruition.
Okay, well, it's perfectly fine. So they will describe how this two-stick method does track the stars, and I now will turn around and say, yeah, but in reality, if you do that in actual real world, get away from the computer, go out and do it, really, it does not track the stars or the sun.
No, but it does. Stop. But it does work. It works for them in the middle of a globe and for us just on a plane without pretending to be in hell. It just works from a plane. So you're saying, but if I take the bit that doesn't work, the extended globe that's wrapped around the plane that it does work on, it doesn't work. Yeah, okay, fine. Yeah, okay, it doesn't work on the surface of a globe. But they're never going to make that argument because they're going to transpose it inside the globe, because that's where the back engineering of the globe originates. So it's it's critical that you, the audience, anybody listening, recognizes that. Rather than saying the globe on the surface fails with the stick pointing to Polaris with another stick off it. Okay, off the surface that doesn't work. Fortunately, the globers have got an explanation for that because you're not paying attention to the parallel light rays. That means we can measure these angles with respect to the center of the globe and turn the globe like it's a protractor, which is what they actually do. But all that really means is you're measuring a flat Earth. That's the critical bit.
Hang on, I don't know if you're following. Let me just ask you a question. With this example that I've given, what do you think is going to happen if it's actually done on this real flat world? If you actually go out, stab a stick into the ground, point it into Polaris, create an arm, and try to track a star, will you be able to track it without changing the angle between the arm and the stick or not?
Why would I be doing this? Will this save my life at sea? Does it have a practical application? Can I make money from it? Can I sell it as a course?
That's not an answer to my question.
So it's useless. What I can do with a line to Polaris is figure out my latitude with just that line to Polaris and a protractor. No expensive tools. I'm just explaining how I can... Excuse me. You've challenged me to whether or not I can just do this on the surface, and I can say no. But I can do something similar, pointing stuff to Polaris. It tells me latitude instantly.
Yeah, it does. I know.
Right, so that's useful.
That's what I've asked you.
That's useful.
I know that it's useful.
Stop.
I know.
Okay,
I don't know why.
Okay, so that proves Earth is measured flat, and that's how that system operates. I don't need interruption. I just need to reiterate my flat Earth proof because I'm proving Earth's flat. That's useful. One step, angle to Polaris. What does it give you? Latitude on a flat plane. The angle can only come from a flat plane, and it's describing circles of equal elevation with respect to Polaris. Equal elevation, that's a flat Earth. That's a flat baseline. That's a flat Earth angle measurement of this star. You want to take us to La La Land so we can juxtapose our globe that doesn't really exist and only comes to fruition by measuring this exact same angle to Polaris. Doesn't work if we stand on the surface, even though when they describe it, they won't be describing it from the surface. They'll be describing parallel light rays that converge at the center of Earth.
Yeah, okay.
Yeah,
I give up on you. I cannot get you to answer a simple question because you just keep trying to derail it into something that you want to talk about.
Your whole thing is irrelevant. You're not paying attention.
I am paying attention, but when somebody asks you a simple question, yes or no question, and you don't want to answer it, you want to answer it by saying it's irrelevant, then the person cannot talk to you. Because if they're talking to you about something that is relevant to them and they want to see how you think, and how you reason about things, and 90% of your answers are, it's irrelevant, but the Globers will do this, then it's impossible to communicate to you. I cannot get anything across.
Like Globers think.
Okay, well, maybe you can acknowledge one of the points that we've put back to you, which is to say, would you not see the importance to first acknowledging how Earth is measured flat with an angle to Polaris? Because that's part of your example.
Well, you see, when I answer your question, I say yes. I don't go, but it's irrelevant. I don't go, but, oh, the Globers will do this and that and the other. It's impossible to squeeze any kind of a... Listen to what I'm saying. I just need a few seconds. I won't go on rant.
For over an hour. Holy shit. John, go ahead.
Okay.
What were you going to say?
My point was that I cannot get an answer, simple answer from you guys most of the time. When you ask me something, I usually just answer by yes or no. This is how I think. This is how I don't think. I don't go on it's useless. It cannot be used. And just derail the answer in the question. It's impossible to communicate like that.
John's going to answer your question. Go ahead, John.
You are asking us about a simple yes or no. We're pointing out that the emperor has no clothes. You're trying to set up a dichotomy of invisible clothes versus some other model. We're pointing out he's naked, and you're saying that's irrelevant. What are we trying to do then?
No. You got me wrong on the irrelevant part, and you guys are most of the time trying to get back. When I said initially the first time it's irrelevant, that was not to say that the fact that the Earth is flat is irrelevant. When I used the phrase "it's irrelevant," it meant it was directed at the fact that in that procedure that I used, it was irrelevant whether the thing into which I'm stabbing the stick is round or flat or cube or any other shape. That's where the irrelevant phrase was meant to. You immediately redirected it to meaning that I think that's the fact that the Earth is flat is relevant. That's not it.
No,
The
but you-
irrelevant
you're-
part simply
You
meant
asked Nathan.
I followed that completely. What the hell are you babbling about?
I don't know.
Sticks in the ground.
It's been going on for over an hour.
Okay, what's it? Let's make this simple. What's your claim?
So my claim is that when you do this procedure that I've done, that on a hypothetical ball Earth, you can track stars like that. But in the real world, outside, if you actually go out, stab that stick into the ground, point it into Polaris, spray that arm, and try to track some star, you won't be able to do it because the star will move in a different pattern throughout the sky, not according to that
So
arm.
what's the
When
claim?
what-
What are you trying to prove?
I'm trying to prove that we're not rotating. That the fact that the star trails, the shapes, the way that the stars are moving throughout the sky does not come from the fact from the hypothetical rotation of the Earth, but it comes from something else, which we know that is the fact that the stars are moving above us and not because
So you're
we are
trying-
rotating.
You're trying to prove a stationary Earth with a stick pointing at Polaris and another stick and another part of the stick pointing at another star. You think that that's going to prove that the Earth's not rotating? Really?
Exactly.
Okay,
That's
well,
exactly
go out
it.
and do it. We want you to go out and do it. All right?
Okay,
Get the video
I'll
camera.
record it. Okay,
Go out and do it,
I will do that.
then come back. then
Okay,
come
no
back.
problem. I'll do exactly
then-
that. I'll do
Okay.
exactly that.
And then connect your non sequitur because right now you're in a non sequitur.
Okay, so Vitamin EH says, I stabbed an angry badger once with a broad tip bow. Fecko was charging me. Well, fair enough.
Was the badger
Well, he
rotating?
wasn't get-